Pre-statistics. Integer exponents, Part 2. Lesson objectives. Use property of exponents to simplify expressions. Simplify expressions involving negative integer exponents. We'll begin with an example. Example 4. Simplify, and we have 4 problems. We will simplify each of these problems using the property of exponents that we saw in the previous video. Let's begin with number 1. We have a base of 2, a base of b, and a base of c, and all this is being raised to the 5th power. Our first step is to multiply every power for each base by 5. So the exponent of 2 is a 1, so 5 times 1 is 5, so we have 2 to the 5th power. B has a power of 2, so we take 5 times 2 and we get 10. Next we have c to the 3rd power. It's being raised to the 5th power, so again we can multiply and we get c to the 15th. 2 to the 5th is 32, b to the 10th, c to the 15th, and we are finished. There are no parentheses, all the exponents are positive, and we have 3 different bases. Number 2, first we want to see that we have this expression multiplied by this expression, so we're not raising powers to powers. So now we can multiply the numbers. 3 times 2 is 6. We have b to the 2nd times b to the 6th, so we will add these two up, and then we have c to the 4th times c squared, and that will be c to the 6th. So our final answer is 6, b to the 9th, c to the 6th. Number 3, we have no powers to powers. We are dividing. So first, if we start with the numbers, we have 3 and 12 simplifies to 1 over 4, and 1 times b to the 7th, b to the 7th. Next, if we look at the base of b, we have b to the 7th in the numerator, b squared in the denominator. So when we divide, we subtract the exponents. 7 minus 2. And then for the base of c, we have 6 on the top, 5 on the bottom. We subtract those two, 6 minus 5. Next, we perform subtraction, and we get b to the 5th times c divided by 4. Number 4, so now we have division, and we're also raising it to a power. The first step will be simplifying the parentheses first. So we have a base of 24, a base of b and c, and we also have a d. So looking at the numbers first, 24 over 16. What does 24 divided by 16 reduce to? Well, 8 will go into 24 3 times, and 8 will go into 16 2 times. Next, we want to subtract the powers for b, so this will be 7 minus 2. We want to subtract the powers of c, so this will be 8 minus 5, and then the d to the 3rd power will stay at the bottom. So this simplifies to, we have 3 over 2, we have b to the 5th, because 7 minus 2 is 5, 8 minus 5 is 3, and then the d to the 3rd power stays in the denominator. Next, we're taking powers to powers, so every base will have its power multiplied by 4. So this will be 3 to the 4th power, b to the 5 times 4 power, c to the 3 times 4 power, 2 to the 4th power, d to the 3 times 4 power. Simplifying, we have 3 to the 4th, b to the 20th, c to the 12th, over b to the 4th, d to the 12th. c to the 4th is 81, b to the 20th, c to the 12th, all divided by 16, which is 2 to the 4th times d to the 12th. Warning, 3b squared and 3b quantity squared are not equivalent. 3b squared means 3 times b times b, and 3b quantity squared means a base of 3b. Therefore, that will be 3b times 3b, which is 9 times b, which becomes 9b squared. So 3b squared has a base of b, and 3b quantity squared has a base of 3b. So whatever's in parentheses will be our base, and then we multiply it by itself, the number that the exponent is. So a typical error looks like this: 3b quantity squared equals 3b squared. That is not correct. We have to distribute this power of 2 to both bases, the 3 and the b, which gives us 9b squared. Let's go back to our powers of 2. So as we increase the power by 1, the number gets larger. And each time it gets larger by a factor of 2. So if I take 2 and multiply it by 2, I get 4. If I take 4 and multiply it by 2, I get 8. 8 times 2 is 16. So we would say as the power increases by 1, the product increases by a factor of 2. So 2 to the 6th power is 64. 2 to the 7th power is 128, so on and so forth. Now if we look at it as decreasing, so if we go 2 to the 5th to 2 to the 4th, 32 to 16, then 16 to 8. So what happens here is we are cutting the value in half, or we're dividing by 2. So we could say as the powers decrease by 1, the product decreases by a factor of 1/2, or is cut in half, divided by 2. Now using this idea here, we can now state what is 2 to the 0 power. Well, if we follow the pattern, 32, cut it in half, 16, cut it in half, 8, cut it in half, 4, 4, cut in half is 2. So if we drop one more power, 2 to the 0 power will be half of 2, which is 1. So it actually turns out that any base raised to the 0 power will be equal to 1, except for one base, 0. 0 to the 0 power is undefined. So what is the meaning of b to the 0 power? Well, it means if m and n, the powers, are the same and the base is the same, then we'll have b to the 0, which is equal to 1, because b to the n divided by b to the n is equal to 1. Now this only works if b is not equal to 0. 0 to the 0 power is undefined. So definition: when b is not equal to 0, b to the 0 power equals 1. So 7 to the 0 power is 1, a base of -3 to the 0 power is 1, and a product like AB raised to the 0 power is 1, as long as AB is not equal to 0. If you take 0 and raise it to the 0 power on the calculator, it gives you an error domain, which means 0 raised to the 0 power is undefined. It's not a real number. Lesson objective: negative exponents. Introduction. If n is a negative integer, then what is the meaning of b to the n? What is the meaning of a negative exponent? If the property b raised to the n power divided by b to the n power equals b to the m minus n power, then 1 over b to the n is the same thing as b to the 0 power divided by b to the n, and since these bases are the same, we subtract. 0 minus n is negative n, so that is the definition of a negative exponent. B to the negative n power means 1 divided by b to the n. So let's look at it using our powers of 2. So we know that 2 to the 0 power is 1. The question is what is 2 to the negative 1? Well, if we think about it, the pattern, we half, we half, we half, we half, we half. So if we take 1 and half it, we get 1/2. 2 raised to the negative 1 power means my numerator will be a 1 and then whatever this value is, I stick it in the denominator. So next, what is 2 to the negative 2 power? Well, that would be half of a half, which is 1 over 2 squared, or 1/4. From our definition, b to the negative n power means it is equal to 1 over b to the n. So if we have b to the negative 3 power, that's really 1 over. So if we have 2 to the negative 3 power, that is equal to 1 over 2 to the third power, which is 1/8. 2 to the negative 4 power is 1/16. 2 to the negative 5th power is 1 over 32. So let's verify this using the graphing calculator. If I take 2 and raise it to the 0 power, it tells me it's 1. If I take 2 and raise it to the negative 1 power, it's 0.5. If I take 2 and raise it to the negative 2 power, it tells me 0.25, which if I change 0.25 to a fraction, the answer is 1/4, or 1 over 2 squared. 2 to the negative 3 power is equal to 1/8, or 1 over 2 to the third. So let's define this. If b is not equal to 0 and n is a counting number, then b to the negative n power equals 1 over b to the n. In words, to find b to the negative n, we take its reciprocal and switch the sign of the exponent. For example, so 3 to the negative 2 power is equal to the reciprocal, and then we change the sign. Now I like to sort of think any time that you move a base up or down across the line, you have to change the sign of the exponent. So since 3 raised to the negative 2 power technically is the same thing as 3 raised to the negative 2 power over 1, you send that base to the denominator and then you change the sign of the exponent. And 1 over 3 squared is 1/9. b to the negative 5th power, again, think of this as over 1. To make the exponent positive, we have to send it to the denominator. Thanks for watching.